How do you go from having a monolithic application to microservices, and how do you build teams and processes around increasing development velocity? In this episode, we find out with James Judd from Lucidchart. So James, welcome to Scale Your Code. It's great to have you here.
Thank you. It's great to be here.
Let's start with a little bit talking about you. How did you get started in this industry?
I was originally a finance major in school. And one summer, a professor in the atmospheric science department was interested in having someone do some Perl development over the summer. And I said, okay, I'm interested, kind of, the money would be great, but I didn't think I wanted to do programming. My interview was, do you know Linux? I'm like, yeah, I've used Linux before. Great, you're hired. So I did Perl over the summer, and by the end of the summer, I was like, crap, that was actually really fun. So I had a mid-college crisis and decided, I actually want to do computer science instead. So I finished my finance degree, did computer science, and the rest is history.
It's funny, when I first started programming a little bit, I'd never thought of that as a career. In fact, when I looked at it, when I looked at some career opportunities, from school guidance counselors or whatever it is, they never showed that as an opportunity at the time. And so I never thought, oh yeah, this is actually something you can do to make money. So that's always interesting when you find out, wait a minute, I do have a skill that can make some money. This is great. But just in case there's people in the audience listening that have never heard of Lucidchart, just to give them some context, can you kind of give us an overview of what Lucidchart is and how it works?
Yeah, so we're Lucid Software. We make Lucidchart and LucidPress. These are tools that kind of help people communicate more clearly. They're online in the browser, collaborative editors. You can use Lucidchart to do things like make flowcharts, entity relationship diagrams. You can also diagram your entire AWS account automatically in minutes, things like this. We also make Lucidchart, which is a tool to kind of make flyers, magazine, newspapers, etc. when you need to really stay on brand. So like franchises, real estate, things like that.
You have a beautiful dog, by the way, completely unrelated. I just saw that a beautiful, is that a husky?
Oh yes, that's Kona. So he's a Malamute.
That is a nice big dog. Anyway, back on topic. So you started, I believe, at Lucidchart as a software engineer, and you're now an engineering manager. Can you kind of talk about some of the skills that you've had to develop, going from just being a software developer to having to manage other software developers, and what that transition's been like?
Sure. So I think one of the most important things to do as a manager is you got to learn to hire and retain the best people and to somehow get results. It's really weird because as an engineer, your work is the deliverable. You're directly working on it. When you become a manager, your team becomes the deliverable, which is really, really scary. You have to build up trust with your team. You have to develop a great relationship with them. And then I'm a huge proponent of servant leadership, kind of serving as that shield of kind of absorb distractions, miscellaneous meetings, maybe the small bug fixes or things like that. And then kind of taking that and helping your team succeed. I found that if you kind of let people, like you find what people are interested in, challenge them along those lines, people oftentimes surprise you in a good way.
One of the things that we talked offline, and by offline I mean off the recording, is also the ability to delegate. So I know that this is, for a lot of first-time managers, might be one of the hardest things to do, is learning how to delegate, learning how to get those results from the team, not necessarily your own output, just like you were saying. What are some tips that you have in terms of learning how to delegate and making that work happen through your team?
One of the biggest things with delegation is trust. If you can trust that you'll ask someone to do something and they'll do it and they can get it done well, that makes it much easier. So I think developing a great relationship with the people on your team is very important. And I think having weekly one-on-ones is a great way to accomplish that. You meet with someone on your team for 30 minutes, have a check-in, see how they're going, see how things are going. If there's something that's brewing, you can catch it much earlier. You can resolve it. It doesn't sit there and fester. I think it's a great way to build trust to help delegate.
What are some ways of measuring some of that success? So you mentioned the one-on-ones and things like that, but how do you ensure that they're successful? How do you show them what success looks like so that they're really able to own that position and get results and succeed in their position?
Sure. So I think there's kind of a few different levels of measuring success. I think it all starts by having a solid foundation. So we set very clear expectations, kind of a description of what we expect people to be, like the level we expect people to be at as an engineer, how they can meet those expectations, how they can exceed them. And then we'll set individual goals in a sprint. So we do kind of 2-week sprint development cycles. And then are you meeting your sprint commitments? And then we'll set like kind of quarterly goals, which we call OKRs, objectives and key results. And we'll set those kind of around business results we're interested in seeing. And are we hitting our OKRs? And then ultimately it comes down to, is the business succeeding? We're doing all of this so that the business can actually succeed. So I think that's kind of setting that foundation, meeting your sprint commitments, hitting the OKRs, and helping the business succeed. That's kind of how we would measure success.
We actually use the same system. We use OKRs here at Linux Academy, and we use a very similar process, having those OKRs defined on a quarterly basis so that then each individual team member knows has that internal compass, right? They know, okay, this is the direction I need to head in. Now, a lot of times, even though it's part of an OKR, it doesn't mean that that's the only things you're going to be working on, because you might have other requests that come in, things that are unexpected, other team members that need help. But having that internal compass that you can go back to and that can guide you towards that direction, that again helps with some of the strategic goals that the organization has been super helpful for us. It sounds like it's been helpful for you guys as well.
Oh, totally agree.
Now, one of the reasons that I was asking you some of the questions is obviously since you're in that management position, but also I'm curious to hear from the audience if you guys want us to spend more time on questions like these in terms of management, in terms of learning how others are doing it, how they're structuring their teams and things like that. I'm trying to get a sense for the audience and seeing how many in the audience are more interested in the actual architecture, the technical challenges, versus maybe they might like to see some management tips sprinkled in through there. So please leave some comments. Let us know what you think about that. I'd love to hear it. Now, moving on to more of the architecture, speaking of which, can you kind of describe what that Lucidchart architecture looks like, just in a nutshell?
Sure. So we serve a kind of a rich web application on AWS using microservices. So our front end is comprised of Angular, TypeScript, WebGL, and the Google Closure compiler. Mm-hmm. So we use WebGL because we do all of our own rendering. You get into the actual editor, this little rectangle where the actual editor is. We do all of our own rendering, so it's pixel perfect across different devices. And then on the back end, we're using a bunch of Scala microservices. And as I mentioned earlier, we're hosted on Amazon.
And I want to dive a little bit deeper into that. We also use some Angular, and I was asking some of our engineers if they had any questions. So we'll dive a little bit more into Angular, but I'm also curious about, you had mentioned previously that you guys used to have a PHP monolithic application that you ran, and then you moved over to the Scala microservices that you just mentioned. First of all, why the change? Why did that happen?
Yeah, so Lucid had been around for about 2 years when we decided to switch away from PHP to Scala. We were constantly having problems with our monolith and with PHP. We're using a framework which had lots of security problems. We had trouble with things like injection and things like this. So we were evaluating different frameworks to switch to in PHP or a different language. The CTO went off and tried things out in Java, in Scala, and PHP, which were kind of the 3 finalists, and came back and said, I really like Scala. Everyone else tried it out, agreed, and we went forward with Scala. And it's been great to move to a microservices architecture using Scala. So those are kind of 2 separate things. It's been great to move away from a monolith because scaling a monolith is really hard. Performance is hard to reason about. You don't know if you're spawning a thread in something that's related to fonts, if it's going to impact document saving. Putting those in completely separate applications or on separate servers makes it much easier to reason about that. And along those lines as well, the failure blast radius was really big. If you chew up resources doing a bunch of font processing, again, your document saving might fail over, and you don't want that to happen. You want fonts to be able to fail independently of your document service. And then the Scala has been great just because we're a big fan of statically typed languages. I know that there's kind of a religious war about that, but we can catch a lot of bugs at compile time that we catch at runtime. And Scala is great because it runs on the JVM. So we get all the libraries, benefits, and problems that come with the JVM. But in general, we don't have to worry about rewriting a bunch of HTTP libraries or something like that. We can just use all the Apache stuff and call it good.
It's funny, I told you this as well. I messed a little bit with Scala. I really didn't do a whole lot with it, but the little that I did, and I know Davis behind the camera here has also messed with Scala a little bit a few years back. And it's one of those languages that I could stare at a single line of code for hours on end and still scratch my head as to what it actually does, which is hilarious. It's beautiful in its own right, though. I do have to give credit to that. It is a beautiful language. But my second question was going to be why Scala, and you just answered that. But in terms of the actual rewrite itself, how do you go from having this PHP monolithic application to rewriting into microservices, how do you even approach that kind of project? And the reason I ask is because we have also gone through some of these rewrites for parts of our applications. And one of the issues that comes with that is obviously you have limited resources. So when you have limited resources, how do you maintain, or when do you maintain the current existing application, and how many resources do you put behind that to fix bugs and add new features, versus how many resources do you throw behind the actual rewrite itself, especially if it can take a while? What would be your advice into how you guys approach that?
Sure thing. So what we did is we started off by saying all new services that are not going to be part of the current monolith are going to be written in Scala. And that was kind of how things were for about a year or so. So I think they went through and one of the first things they did was they wrote a document service because they wanted to greatly expand the capability and collaboration that we had. So that involved ripping some code out of the PHP, but a lot of it was new stuff. And then a few years later, after we've been writing some new services in Scala, they decided, okay, we're going to start migrating all of the PHP to Scala. So we set up, at first it was ad hoc. We set up a leaderboard, how many lines of PHP have you converted to Scala, then generated a little bit of internal competition. It was fun. Every line of PHP we converted into 10 cents or a penny or something like this towards an engineering team activity where we all went and played laser tag or something like this. But that only got us about a third of the way there. So we dedicated a team of about 4 to 5 engineers for 4 months at the end of 2015 to kind of take us over the finish line. So that's primarily how it got done, was just taking a team of engineers and having them focus on nothing but it for a third of the year. But we did get a fair amount done just doing things kind of ad hoc.
What about with Angular? When did you decide to switch to Angular, and what were you using before then?
We were using, so before we switched to Angular, it was a mix of jQuery and an internal templating language based on jQuery it was not very good. It was not very fun to use. So we decided to switch to Angular, the Angular 2 at the time, the day after it came out of alpha. So we decided to do a new version of the Lucidchart editor using beta Angular at the beginning of 2016. And we spent a few months on it. We got a good chunk of it done. We hit some conversion issues that we worked through with Google. But that's kind of when we decided to switch over. It was just, hey, we're taking a big crack at refreshing the UI. We could do it in what we have now. We could try to make what we have now better, or we could just use Angular. And we decided to use Angular.
Can you talk a little bit more about the integration of Angular itself? So are you using it or integrating? How does that integration work between the front end and the back end through Angular specifically?
Sure. So what we've got going on is we have Angular that is primarily dealing with the kind of UI, the menus, components, various things like that. And then a lot of the business logic will be just kind of TypeScript code. And what will happen when we're communicating between the front end and the back end, integrating kind of our Angular UIs with our actual back end, is we've got a REST API on the back end where we have someone who's a really big fan of like REST, full REST, like Roy Fielding style REST. Mm-hmm. So we use Hypermedia as the engine of application state. Everything returns URLs. So what ends up happening is the TypeScript code or our iOS code or our Android code or our integration code will contact a bootstrap URL, sending an accept header saying, I want this particular version of it and I want it in JSON. And it gets back links to, okay, here's where you can go to contact user service. Here's where you can go to contact document service. You contact user service. Okay, here's where you go to get this information about a user. Here's where you get information about this user subscription, this sort of thing. And you kind of just follow these links hypermedia style until you end up with the resource you want. The advantage of that is it makes it really easy to version your API because the bootstrap URI stays the same, and then you just accept different MIME types whenever you need to mutate the data model. The biggest challenge with it is that it's very chatty. If we had zero latency between client and server, this would be fantastic. But over more high latency mediums, you do see a little bit of issue because round trip times are much higher. But for the most part, people are using the application from desktop computers at work. So in general, it works pretty well for us.
And do you have dedicated full stack developers that focus on the front end and focus on the back end separately? Or do you have full stack developers that focus on both at the same time? Or you know what I mean by when I say at the same time?
Yep. So we have every engineer that we hire at Lucid, we hire full stack. So we like to hire smart people who can get things done and figure we can teach them the rest. And so we get these full stack engineers that kind of spend some time on teams. We switch teams up 3 times a year where they can, like, on a particular domain of the product. So some are more front end, some are more back end, some are more integrations, or some are more mobile. But at the end of the day, we expect people to be able to work from front to back. Granted, at any given time, you're probably working on largely front end or largely back end. But I've worked all the way from infrastructure on the DevOps team all the way to writing CSS on our front end, and I really enjoy that.
Awesome. And when it comes to code standards, how do you really enforce those or even define those for the teams?
Yeah, what we do with code standards is we have automatic formatting and linting, which is actually relatively new development. It's only about the last 6 months or so when we finally got big enough that we decided we needed the automated tools. I figure that really helps enforce style and catch some gotchas or some quirks at Lucid that we like to enforce. And then beyond that, it's code reviews. We'll say, okay, all code before it gets merged into master goes through a code review. You assign somebody who is an expert in the code, and we'll use some plugins that try to smartly figure out, okay, here's people who have been working on this file. They probably know what it is. Assign it to one of them, get some code reviews, get a QA, this sort of stuff. And that helps us keep our code base sane and the code of pretty high quality.
Speaking of which, we talked about some of the processes that you guys as a team have implemented to help with some of the development, speed up the development and things like that. And you mentioned that some of those that have been very helpful and positively impactful have been, one of those is releases once a week, and then having smaller teams of about 8 people or so. And then finally, you talked a little bit more about the on-call team. So can we let's start first with the releases once a week. First of all, how did you even achieve those releases once a week?
Yeah, so we used to release once every 2 weeks. Ever since I joined Lucid 3.5 years ago, we've been releasing once every 2 weeks. So we had a 2-week sprint. The sprint would happen on the Monday after the sprint ended, which would end on a Friday. We would cut a release candidate branch. That release candidate branch would go through a manual QA regression, blockers, and would be fixed. And then we would release to production on Thursday afternoon. What we did to get it down to a week is we took a look at what services we were releasing once every 2 weeks. Some of them we decided, okay, we have high enough test coverage here that we can just continuously deploy this. And we just started continuously deploying a lot of our backend services that are low risk and aren't likely to break anything too bad if they break in production. And then we started working on, as well, automating a lot of that manual regression. So we have a dedicated QA team at Lucid, and they're awesome. But you can't have people just doing regression all the time. It's just going to burn people out. So what we did is we took an engineering team and we said, okay, let's get our end-to-end tests in a better spot. And hold on, someone's going to answer the door here real quick. So
that is a beautiful dog. Seriously, I love huskies. They're so pretty.
Yeah. What we were doing is we took an engineering team. We worked on cutting down a lot of that manual regression we were doing. So we wrote a lot of end-to-end tests. We did just all sorts of stuff that we could do to make that QA regression cycle shorter from like a full week to just a couple days. And what we did is, as we were cranking, we were improving the regression time from 5 days to 4 days to 3 days to 2 days. We changed our releases to go correspondingly. So we said, okay, we're not going to release every 10 business days. Now we're going to release every 9 business days, then 8, then 7, then 6, and so on and so forth. And we eventually reached 5 business days per release. We just release now every Thursday, which is great, or every Wednesday rather.
Can you speak to some of the positive impacts that has? And the reason I bring that up is because I'm willing to bet we have people listening to this right now who are not there yet. Their organizations are not anywhere near that, and it could take a tremendous amount of investment to even get to that point. So when does it truly make sense to put forth that investment, and why, and what is that impact?
Sure thing. Yeah, and I will definitely say that it takes a lot of investment. It took us about a full year, and it was not an easy year to get the weekly releases, but the benefits have actually been great. We used to see a lot of changes that would be released as hot fixes or emergency releases, we like to call them, to production, because some teams, it says, hey, this is going to go out in 2 weeks, and it's all, no, I need this sooner than 2 weeks. We just want to tweak something on a marketing page, or we want to tweak this A/B test, or we want to do this thing. And those don't happen anywhere near as frequently. There's something magic about, okay, that's going to go out next week. I don't have to worry, versus 2 weeks. And so we saw a massive drop off in those, which is fantastic because that means a lot of things will go through and they'll actually be QA and there's less risk of breaking the production system. And then one thing that was actually surprising, didn't expect it to be as big of a benefit as it was we decoupled sprints from the release cycle. Sprints in the release cycle used to be in lockstep. Once every 2 weeks, we cut an RC candidate at the end of a sprint. The big challenge with that is on the Friday afternoon at the end of a sprint, there would be this massive wave of pull requests that would just be merged. Like things would be going along pretty steady, and then just bam, like it's like 50 to 100 commits, or even more that would just get merged all at once. And master would go from stable to just a giant mess, and you'd have to spend a bit of time on Monday and Tuesday cleaning everything back up because all these things getting combined at once caused regressions. And when we see that, hey, we're decoupling the sprints from the release cycle, you're not rushing to meet your sprint commitment and get everything merged right at the end of the sprint, it's been really great to have that. Things stay more stable, the change sets are smaller, been a big fan of it.
The next implementation that you mentioned is keeping those teams a little bit smaller, so having about 8 people per team. Can you talk about why that's important and also how or what those teams are comprised of?
Yeah, what we have about 8 people per team. This will usually be 4 to 5 engineers, a QA specialist, a product manager, and a user experience designer. And what we do is the engineers are the people working in a specific domain of the product. So you'll be working on, say, our data linking stuff or our AWS integration or integrations and enterprise team or something like this. And you have a product manager who is very familiar with that part of the product. You have a QA specialist who's embedded on your team. They'll work with your team and maybe a couple other teams. They're familiar with testing your part of the product. And a UX designer who is familiar with that as well. And we find that these integrated teams do really, really well because you don't have somebody who is disconnected from the team who sits down and says, okay, now we got to plan out a sprint. No, they're with you on a day-to-day basis. They know what's going on. These kind of cross-functional teams, we think, really help us achieve a better product.
We don't currently have a user experience designer part of the engineering team, so that's actually something that I'm pretty interested in, and we'll have to see if that's something that makes sense for us as well. But no, I could see the benefits of having that, especially when otherwise you might have some different sprint plannings and something might pop up that we need to create a design for that was not originally thought of because the task wasn't broken down there or wasn't thought through and things like that. So I could see that being beneficial for a number of reasons, specifically that use case that just popped in my head as well.
We've been to that point. We've been a really big fan of having UX designers directly on the working directly with the engineering teams, because you get a UX designer, they know what's being worked on that sprint. They'll go talk to an engineer and say, okay, your component, you've got this thing in the design, and it's kind of infeasible to implement like this, or hey, can we tweak it? I've sat down and I tried to use it, and I think this worked a little bit better, and they can pull them over to their machine while they're working on things. And we think it really just helps speed up development when you don't have to wait for another cycle to start for a different team or another sprint or anything like that. You can just day to day pull them in and get feedback and work on it as things are moving along.
Because even if you have a very well thought out scope with wireframes and designs, and you look at those designs and you say, man, this looks fantastic, this is going to be awesome. Once they put it out on a web page, sometimes it can be entirely different. You go through it and you're like, man, this is not as good as I thought it was. And there's just a disconnect that's very hard to get around. So again, I could definitely see that being useful for sure. Thank you for that. The last thing you mentioned was having these on-call teams. You kind of explained what the on-call teams are responsible for and some of the changes that you implemented in that. Can you tell us a little bit more about that?
We've had an on-call team structured this way since roughly I joined Lucid. I joined it about a year and a half ago. What we have is back then we had a very small on-call team. It was about 5 to 7 people because we didn't really have different tiers of access in our on-call. You either were unprivileged or you had root pretty much everywhere, which we've since changed. There's now intermediate levels, but that's kind of how it was back then. So it had a very small group of people that were embedded throughout the engineering organization. And you'd take on call once, I would just cycle through everybody. So once every 7 weeks or something like this. And when an alert went off, you get paged because something's broken. You'd hop on, you'd triage it, you try to get things healthy again, and you'd move on. And we love embedding these people directly in the teams because it's really easy to become disconnected as an engineer working on an engineering team that never deals directly with production. You write your feature, it gets shipped to production, you use it when you use your product in production, but that's about it. But now you write a feature, you ship a feature to production, it has scaling problems. Somebody from your team or somebody else in the engineering organization, maybe your good friend or something like that, gets paged the night before, they come in all haggard the next morning, you're like, man, that's not great. I woke so-and-so up at 3 a.m. last night. And if somebody's on your team, they can talk about that and you kind of see that impact and you feel a little bit more ownership of production when there's an on-call person directly on your team. It also empowers the team to, if they need to do a hot fix release or something like that, they can do all that directly within the team and they don't have to go to a special on-call team or the DevOps team to get a release approved. They can release it. They're responsible for it. If it breaks anything, they can go fix it.
I do want to ask you a little bit more about some of the monitoring and tooling around maybe errors or even performance or things like that. Before we do that, let's talk a little bit more about some of the other teams that you guys have and how you've structured those, and also maybe also some of the AWS services that you're using, since you did mention that you run on AWS. So I guess let's start first with the team structures. I know you have a systems team and a backend team. Can you kind of talk about what those teams are comprised of and what they represent?
I work directly with our systems team and our enterprise and integrations team. So our systems team and our backend team are pretty much the same team. We've got a DevOps team that will be more so. How this relates to DevOps, because these are kind of our two back-end teams, is systems is kind of our back-end applications team, and DevOps is kind of our more back-end infrastructure team.
Got it.
So systems is responsible for the scalability, reliability, performance, and architecture of the application. And then DevOps would be more responsible for, they're responsible for a lot of the same things, but they approach it from, do we have the server capacity? Are we using the right services? Do we need to do the more infrastructure related things? So systems team, we've done all sorts of fun things. We occasionally will go in and optimize or rework parts of the architecture that we've outgrown. Sometimes we'll do the more technical parts of the product. We don't actually have a product manager on the systems team because we tend to tackle the things where a product manager wouldn't be as useful because there's pretty much no front end or user facing component of it, but it's still important to have encryption, security, performance, things like this. And then for the rest of the engineering organization, we have teams that are broken down kind of by domain for the product. So we've got an enterprise team, an integrations team. We've got a team that's related to our data linking and data visualization features, things like that. And as their names might imply, enterprise works on things that enterprises care about, like identity management and security and things like this, and integrations integrates with things. And our data binding team works on our AWS integration and hooking up with Google Sheets and visualizing data and stuff like this.
Let's talk more about that infrastructure. You mentioned running on AWS. What are some of the services that you use, and what do those services serve as functions inside of or for your infrastructure?
Yeah, so we use a lot of AWS services. I won't list and go through all of them.
Sure.
Primary ones that we use are EC2. What's where we run all of our services on. Those those are the actual servers that we're running our application on. We use RDS with Aurora. So we can actually store our data. Pretty much everything is SQL. We use a little bit of DynamoDB and things like that, but it's almost all SQL. And then S3, we store a lot of stuff in S3. A lot of files get stored in S3. We also use things like SQS, SES, Kinesis, things like that. So I know that's kind of like a laundry list of Amazon services that we use. I mean, I could talk a little bit more about how the architecture of the infrastructure looks if you would like, but it's up to
sure.
you.
Let's do that. Yeah, absolutely.
Sure. Yeah. So kind of what we've got is, it's nothing too terribly exotic. We've got people requests coming in from the internet. They get routed to Amazon's ELBs, so we can do SSL termination. Then they get passed off to HA proxy, which is our load balancer. And then from there, they'll get sent off to different scale groups for individual services. Because again, we're running microservices. So if you make a request to the document service, you're going to get flown through HA proxy to a particular document service box. It's going to service your request. It's going to send it back. If it needs to contact the database, we actually, just in the last 2 days, we now contact the database directly. We had a database load balancer. We still kind of have a database load balancer, but that's kind of that. That's the flow, kind of how a request to get all the way in through the internet to an application box, to the database, and back out. And then just another random nit is what we're using Chef for management of our servers. So if we need a box to spin up in production, we say, okay, you need to be a document service box. Chef will configure it and run it. We'll bake an AMI, but we'll use Chef to make sure everything stays up to date and security and patches are run and all that wonderful stuff.
When you use different services like that, especially when you have microservices and whatnot, one of the things that's easy to keep in mind is when you have a request, that request can actually touch so many different pieces. One of the issues that you could have there is, what if one of those pieces becomes unhealthy and that response time really increases, or there's an error rate increase or anything like that? How do you guys prevent that? Or if you can't always prevent it. How do you measure that, and how do you make sure that somebody can see this is the piece that's unhealthy, this is the piece that's taking longer to respond?
We don't always prevent it. I wish we could always prevent it, but we don't. So to answer your question as to, I'll start with the monitoring piece, kind of how do we monitor it? How do we know when there's a problem? And then I'll talk a little bit about some of the tools we've built to make our lives easier. So we'll use StatsD and Datadog to measure a lot of metrics around application performance. We'll send those off to Datadog. We will alert on them when, like, we'll track latency. Okay, when latency for this endpoint or for this service is low and is like slowed down past some SLA that we've defined, go ahead and alert. Somebody will take a look at it. When there's enough errors, go ahead and alert. When we'll use pingdom as well. We'll say, okay, constantly ping the document list or the editor, and if you can't get there, throw an alert. Those sorts of things. So that's kind of how we know when things are wrong, is we have a lot of metrics that we'll use with Datadog and Loggly, and then we use our Opsgenie currently for alerting. And that helps us keep track of when things are working well and when they aren't. So in response to some things that we've seen, and these are pretty common problems, you said, with distributed systems in microservices, is like the classic example I like to use is, we'll run into issues with retry storms. So you have service A that makes a call to service B that makes a call to service C, and this call is set to retry 5 times. So if you have the request fail from B to C, it'll retry 5 times. And then if it fails because it's failing from B to C, if it fails from A to B then retries 5 times. And we've all of a sudden got an exponential growth in the number of requests we're going to be making to service C. So service C gets a little bit sick, and all the other services just like there's this exponential explosion of retries. And if service C was sick, well, it's now dead. And what we've done to deal with this is we inspired by Netflix's Hystrix a library, which is kind of like a way to do inter-service communication in a fault-tolerant manner. It does things like circuit breaking and keeping track of requests as they flow through different services, things like this. We ended up writing an internal library that we call Kronos, where we say, okay, so you're going to manage timeouts. This request should be taking this long. If it's taking longer than that, go ahead and stop. If we detected an upstream service is sick, don't just keep trying to make requests to it because it's sick. Give it some time to recover and then connect back to it again. And a great case that we saw this actually work was earlier last year. I guess it was almost a little bit over a year ago now, when Amazon S3 went down. We depend on a lot of things in Amazon S3. We store a lot of images there. We store a lot of fonts there, these sorts of things. And before we had Kronos, the site would have probably just been down because we would have been depending on S3. It wouldn't have worked. What ended up happening was we went degraded, but we didn't go down. We tried to contact S3. It failed. We just flipped a circuit breaker, and that circuit breaker didn't flip back up until S3 started to become healthy again several hours later. So people didn't have images, people didn't have fonts, which, I mean, arguably, if you don't have images as fonts, how useful is it really? But you could still go in there and edit your text. You could still open documents. If you still need to get to something, you could still use the product. And that was really cool to see that in action. So yeah, that's kind of I think that answered your question. Yeah. Kind of just like, how do we measure it and what have we built kind of around it? Yeah,
that's excellent. Do you have another example of maybe other pieces of your application where you have that kind of switch, or is it primarily focused around those images and fonts? I'm just trying to think of the perspective of how modular can you make that application so that if that system goes down, it doesn't impact the rest of it.
Sure. We actually wrap every single client, internal and external, now gets Kronos is used with it. So if you're making a request from our document service to fonts and images, or our document service to our user service, or the spelling service, or whatever, all of these different clients use Kronos, and even externally. So if we're making a request to, Salesforce, if you're making a request to, HubSpot or Marketo or something like this, you're going to end up using Kronos as well, just because what we don't want to have happen, and we've seen instances where we have retry storms and things blow up. We've also seen instances where we'll do things like we'll completely consume a thread pool, and the default behavior or level like a connection pool or a thread pool will just be to block forever. And so you end up with this infinitely backing up queue until either your service crashes because it runs out of memory, or because or everything just crashes because nothing's ever getting done. You have thousands of requests coming in, but they're all blocking at this single point. This is why we've developed something like Kronos, is just kind of handle this this chaos that develops in the system.
How do you measure the performance of the individuals or the team that works on that function? And what I mean by that is, do you have a set of KPIs or anything that you track in order to say, okay, we need to have this type of uptime. If this disaster happens, this is how it should be handled. How do you guys measure that?
So what we'll do is we have a set of KPIs that we'll usually track in OKRs. Some of them are like on every single quarter's OKRs, like we usually have an uptime OKR that we want to maintain. Some of them will say, okay, they've been on the OKRs for like a year or something like that. They're not just part of the ingrained culture, so they can come off, but they're still very important to us. Some of these things are that we'll measure like uptime, bug count, the number of, we have a special category of bugs that we call production issues for things that cause alerts to go off. And we want to keep those low, or when they happen, we want to resolve them quickly so that the on-call team doesn't get burned out. Various things around this, but then we'll also measure things like response time, the percentage of healthy requests. We also measure inside the actual editor, which is a little different than probably most web applications, is we measure things like the frames per second we're getting and how many resource stalls we have, or, is there a particular document where performance is just really anomalously horrible or something like this, right? So that's kind of like a lot of different things to measure, but these kind of ultimately boil down to overall health of the application and overall performance of the application.
Let's wrap this up with a wildcard question. You ran an advertising campaign piggybacking off of the doggo craze.
This is a doggo. A small doggo is a pupper. Here's a sad pupper. But a big old pupper, that's actually a doggo. Not to be confused with a big old doggo, because that's a woofer.
You told me a little bit about how that went. What was that advertising campaign, and how'd that go?
We have a video marketing manager named Caleb, and he's an awesome guy. And he ran a couple videos last year, and he got together and he said, okay, we want to really get in touch with the engineers. So we're going to get together with the engineers and figure out what they like, and then we're going to make an advertisement about that. So I got together in a room with Caleb and a few other engineers, and he said, okay, here's some ideas that I have, and I'd love to get your thoughts. And we got to talking, and someone's like, well, and I was like, hey, what about doggos? Like, we got this doggo thing we could do, right? And so then what we ended up doing is we ended up kind of taking, okay, well, the internet has this kind of lingo around doggos. You've got, doggos and puppers and woofers and floofers and subwoofers and like a bunch of these like made up words, right? And so he made a flow chart where he kind of walked people through, okay, this is a doggo, this is a pupper, this is a woofer, this is a floofer. And we posted it on Facebook, we posted it on Reddit. It got a few thousand views. We're like, okay, well, I suppose that was a moderate success. And then I woke up on a Saturday morning. We launched the video on like a Thursday or Friday afternoon, and a friend texted me and he's like, hey, so did you guys make this doggo thing? Because I'm seeing it on Facebook and like it's like blowing up right now. And so we hop on there that Saturday, and we found all these people who were reposting it. Like 9gag picked it up, Unilad picked it up, a few other people picked it up, and something that went from like 3,000, 5,000 views to like 3 million, 5 million views. And then we kind of made a few more videos in that thing. And then the next thing you know, it's like just millions and millions of views, and we're ecstatic about it that we can just take largely nonsensical words from the internet and put them into flowcharts, and they're really, really fun. And it's always really fun to be able to have fun with your advertising and have it actually work.
It's always, or not always, but it's oftentimes the weirdest things that end up going viral that way.
Yes, it's true.
That sounds like a lot of fun, though. I'm glad that worked out for you guys. James, thanks again so much for your time and for doing this episode. I learned a lot personally from doing this, and I'm sure listeners will as well. If anybody has any questions, like follow-up questions or anything like that, or if they're just interested in following you for your work, how do you recommend they do that?
You can find me on Twitter. I'm just James A. Judd on Twitter. You can also send me an email at james@lucidchart.com.
All right, thanks, James, and thanks everybody for tuning into this episode. Like I said earlier, please let us know if you want to see more questions about management and things like that. I know that can help a lot with career growth, so let us know if you want more of that, and otherwise, we'll see you next time.